Alright, so in this video we're going to talk about how to use the matrix notation to calculate our least squares estimator of beta, right, which is this b, and how to estimate the variance of that estimator. Okay. To be honest with you, Excel does have some formulas for matrix multiplication and manipulating matrices, but a lot of times people will start looking to use another program once they want to do some matrix calculations. So for example, R is a really popular program that people that are doing data analysis and statistics will use. It's very flexible, a lot you can do in R, and you have some nice matrix properties that you can take advantage of. Of course, there's also MATLAB, which is pretty much based in matrices, and Octave is a pretty similar program to MATLAB. So you can use Excel. So I'll show how to use it here. The nice thing about Excel is, especially if you're new to matrices and you don't really understand what's happening, it does show you what's happening versus those other programs. If you're not fully aware of what's happening behind the scenes, it doesn't really show you all the steps, which is nice when you have a lot you're trying to do. You don't want to see it all. Okay, but of course, so we have this data here, and of course the quickest way to do a data analysis in Excel is to go up to this top ribbon, press data, and then go over to data analysis, scroll till you get to regression, and then put your cursor in the Y range and highlight your Y data, put your cursor in the X range and highlight your X data. You should always include those labels when you're highlighting your data. And I like to go ahead and include all these residual information here too. So go ahead and just press OK, and it'll put it out on another sheet for us, which is really nice. So this is B, right? Our estimate of beta is right here in the coefficients. So actually, let me go home and let me highlight this guy. All right, we're going to use matrices to kind of come up with this guy right here. Okay. And then the standard error is the square root of the estimate of the variance, right? So let me highlight that guy as well. And then the standard error is also the square root of the mean squared error. So I will highlight that guy as well. So that's what we're going to calculate. We're going to calculate all these, all right? But we're using matrix notation. So really careful. A lot of big mistake people often make first thing is they say, oh, well, here's X. I need X transpose times X. Let's do it, right? They get right to it. Remember, X, when it's written like this in matrix notation, it's the design matrix. So it's not just these X values. Rather, X is a column of ones, right? And actually, let me take this, and I'm going to press Control C and Control V just to paste it right here. And then I have ones that are all next to it. Okay, this is the matrix X, right? It's an n by 2 matrix. Okay, it looks like n here is 10. I have 10. My sample size is 10. So X transpose, right? You're going to want to make sure you're leaving room when you type this out. So equals transpose, okay, and then highlight all your data. Okay, and it asks for an array, so that's a matrix. Press enter, and there we go. Okay. Then X transpose times X. I think I will have room for that here. So X transpose times X equals MM mult. So it's matrix multiplication. Okay, and the first thing you want to give it is the first piece of the multiplication, which is X transpose. And the second piece is X. Okay, and then close parentheses and press enter. All right, and we're seeing what we should expect, right? We multiplied a 2 by 10, a 2 by 10 by a 10 by 2, so we got a 2 by 2. Okay, so then next, if we want to find the inverse of that, so this is x transpose x inverse, right? -1 to the -1 power, the inverse of it. This is m I n v, there it is, m inverse. Okay, and what do I want the inverse of? I want the inverse of this guy. Just highlight it, close parenthesis, and press enter. And there it is. That's the inverse function, or the inverse of x transpose x. Okay, so we have this first piece here. Then we want to multiply that by x transpose y. So let's go ahead and calculate x transpose y. X transpose y. This will equal m mult. So matrix multiplication of x transpose is the first array, comma, and here's y. Now make sure you're not copying this label, okay? Just the numbers. Okay, close parentheses and press enter, and there we go, okay? So this is x transpose y. So I want to multiply these two together to get what b is. All right? So b is going to equal, or b, let me just write it here, equals mult, or m mult, sorry, matrix multiplication of this guy times that guy, right? A 2 by 2 times a 2 by 1. I should get a 2 by 1. Good. And those are my two b's. All right, let's highlight that. Let's see, they should be exactly, very good. Very good. They should have been exactly the same, right? These coefficients, this is basically what I calculated using matrix notation. Good. So I feel like Excel does a good job when they do their data analysis tool pack, right? It basically just proved that this works. Okay, so these guys, these coefficients are exactly these guys. Okay, good. Next, let's estimate this. Now, sigma squared is unknown. So we're going to need to use the mean squared error, which is the residuals, the sum of squared residuals divided by n minus 2. Okay, so let's figure out what our residuals are. So I'm going to make a column here called y hat. All right, so what is y hat? Y hat equals the, I can do matrix multiplication here. So mult, and what I want to multiply is x, okay, times b. Okay, x times b is our estimate y hat. Close parentheses, and it'll automatically fill it in for me. All right. So then, when I want to find next, I want to find what is e, or my residuals. This is y minus y hat, and you press enter. You get your cursor to look like this little black X or cross. Click and drag it down. Okay, so these are my residuals. Okay, so now to find E transpose, let's see, do I have room for it? I have room for it right here. So I'll write E transpose. This equals the transpose of E. Okay. So it's exact same, just transposed. Right? So S squared is going to equal matrix multiplication, so mult, of E transpose, comma, E, okay, close parentheses, and then divide that by our sample size, which we have 10 observations here. So use parentheses, 10 minus 2. And there we go. That is the mean squared error, right? So S would be the square roots of that. Okay, so I think that that's something that Excel told me. So let's go back over here, and there we go, the standard error. That's it. Good. Our way of calculating this using matrices, we found the exact same answer that Excel gave us. The standard error is the square root of the mean squared error, which is E transpose E divided by n minus 2. So we're going to plug that in here and we're going to find the estimate of this variance. So let's do that next. Where do I have room to do that? I am going to put that as estimated variance of B. Okay? And so this is going to equal this guy times this guy. I have already calculated it here. So I can just type it like that, and there we go. All right. So the diagonals are our variance terms, and the off diagonals are the covariance terms. Okay. So if I want to know the standard error of this, then what I will need to do is I'll take, so the standard error of B naught, right, the intercept, is going to equal the square root of this diagonal. Okay, and the standard error of B1 is going to equal the square root of the second diagonal. Okay, so these are the standard errors of B1, which Excel gave me right here. They highlighted it. I highlighted it blue, so let me go ahead and highlight my other side blue. Blue. Okay, so these standard errors are exactly the same as these standard errors. So good, our formula works. Okay, so the diagonals are the variances and the off diagonals are the covariance. So this is the covariance between B naught and B1. Okay.